exams are concerned. Okay, so now I will go with the next concept of the chapter, that is what uniform circular motion. Okay, so uniform circular motion or circular motion will take it is having a lot of extended what concept. Okay, so I'm not going to take all those things now. Let me first follow your board exams or your NCRT. So we will discuss about the centripetal acceleration. Then we can go with the extra things whatever required for circular motion. Okay, so let me in the beginning go with as according to your NCRT. Then we can extend to the different levels. Okay, so what is this uniform circular motion? Okay, uniform circular motion. Uniform circular motion. Okay, so you can write UCM, uniform circular motion. Okay, so what do you mean by uniform circular motion? Okay, so if simply object is moving in a circular path, it's okay. If simply object is moving in circular path, you can simply call it a circular motion. What is uniform circular motion? It is moving with the same speed. It is moving with the same speed. Okay, so speed should be same everywhere. It may be here, or it may be here, or it may be here. The speed should be same. Okay, so then how we can define this uniform circular motion? Okay, when an object moves in a circular path, with constant speed, then motion is called uniform circular motion. Okay, uniform circular motion. Okay, then you may ask me there why you are writing with a constant speed. Why we are writing with a constant speed? Because speed is constant but not velocity. We have to remember this, which is very important. Speed is constant here. What about velocity? Velocity is not constant. Why? Magnitude may be constant, but direction is changing continuously. Here it is having different direction, here it is having different direction, here it is having different direction, here it is having different direction. So that is why the velocity, better not to mention velocity as a constant. It is that is why we are getting acceleration. Why we are, even though the speed is constant, if there is some constant speed, we should not get the acceleration. Acceleration should be zero. Acceleration should be zero. Okay, but here it is not equals to zero. Okay, why? Because velocity is not constant. Of course, if speed is constant, many times if it is straight line motion, your acceleration is going to be constant. But here speed is constant, but velocity is not constant because of what? Because of continuous change of the direction. Velocity direction is changing continuously. So that is why it will get some acceleration. So acceleration is also what having the some directions towards the center. That we will see that what exactly direction and how it will get the values. Okay, so now how we can define it is a object, if it is moving in a circular path with a constant speed, then motion is always what? Uniform circular motion. Okay, so if you talk about examples, if this is the earth, so you can take any artificial satellite or something. Okay, so this is moving with some constant speed, but direction is changing. Here direction is here the direction is different, here this direction is different. So this is what example for the satellite motion around Earth. Okay, so satellite motion around Earth is the better example for uniform circular motion, or you can say the tip of any hands in your watch. They all are what? They all are in uniform circular motion. Only direction is changing, but its speed is faster. So this is also the motion of hands of watch. Okay. So these are the simple examples for uniform circular motion. Okay. So let me talk about acceleration in uniform circular motion. Okay. So acceleration. We'll see whether it is a normal acceleration or it will take some different name or something. So let me see that. So suppose you are having say some center over here. So this is all the circular part. Okay. So if this is the case, at some instant of time, say object is here, say at a point P. Now the object may be at this point. Okay. So P dash, and this is what P. At time P, it is here. At P dash, it is here. To come from here to here, it will take a time. Say it will take time delta t. Path is not only this much, it will take circular path. Okay, so total circular t. So no need to worry about that one. So let me take displacement vectors from, this is what origin. So this is what the radius. So let me take it as say r, and this I will take it as a r dash. Okay. So this I will take it as r dash. So then what is this? This is going to be displacement. So displacement say delta r. Okay. So what about the velocities? Velocities here it is in this direction. This is what v, and here it is in this direction. This is what p dash. Okay. So what angle it is making? It is making an angle say some delta theta. Okay. So if this is the case, so let me write r and r dash are the position vectors. Position vectors at t equals to 0. It is say it is at t equals 0. It is at p. Then some at t equals to t. It will be what? It will be r. Okay. So no need to worry about that one. And v dash are the simply say position vectors at p and p dash. Don't get confused. Okay. Similarly, v and v dash are the velocities at p and p dash. Okay, respectively. So now, if I talk about if I draw the velocity vectors, so what will happen? If I draw the velocity vectors over here, this is what v, this is what going to be v, and this one, you just bring this one and join it to this point. So what will happen? This is what your vector v. This is v dash, and this is p. Now, what is the angle? If this is theta, so the angle between these two is also c delta theta. Okay. So what is the resultant? Resultant will be in this direction. This is what the resultant, that is say delta v. Okay. So why? Because if you apply the triangle law, these two are in same direction. V plus delta v equals to what? P dash. V plus delta v equals to V dash. This is in opposite direction. These two are in same direction. From here to here, P plus V dash equals to, delta v equals to V dash. So obviously delta v equals to what? V dash minus V. This one we want. The velocity, final velocity minus initial velocity, that will give the change in velocity. But if you look at changing velocity, it is in this direction, means it is here along the at the center. So delta v is along the at the center. It is bisecting the delta. It is bisecting the delta. Okay. So that is what if I want to write what is the velocity here. if you write the velocity, so if you write the velocity, it is nothing but v equals to delta r divided by delta t. If you apply limit tends to delta t tends to 0, if you apply limit delta t tends to 0, what will happen? V equals to you can write simply limit delta t tends to 0, delta r divided by delta t. So v equals to, this will become dr by dt. Okay. So this is what about the velocity. What is direction of velocity? Direction is towards the center or change in direction. If you talk about the change in direction, that is what it is toward the center. This is what instantaneous velocities. No need to worry about this thing. These are what instantaneous velocities. So no need to worry about this one. So if I talk about change in velocity, so change in velocity is directing towards center. Is directing towards the center. Now if I talk about the acceleration, so what about the acceleration? Acceleration is what? Average acceleration is say change in velocity divided by change in time. Now acceleration is always what? Always along the direction of what? Change in velocity. So this average acceleration is what? Towards the center. Okay. So direction of average A is along direction of delta V. Okay, that is what towards center. That is towards center. That is nothing but it is towards the center. Okay. So now, if you write the instantaneous acceleration, if you have to apply the what, you have to apply the limit. Okay. So if you apply the limit, so what you can write, or simply I want to replace this over here. So A equals to, we are having, so delta V divided by delta T. So what about the delta V? I want to write something about delta V. If you look at these two triangles, which triangle? P O P dash, and this you can take it as some L M N. Okay, so L M N. So these two are what? These two are similar triangles because same angle is there. So sides are also probably less or more equal. So these two are what? Similar triangles. So from similar triangles, what is that? PO, P dash, and what is this one? This is what? LMN. Okay, LMN. So if triangles are similar, what we can write? We can write a ratio of their sides will be what? Equal. Okay, I will take any two ratio of two sides. Okay, let me take delta V divided by V. So delta V by V, delta V divided by V equals to what I can write? Can I write it as say delta V by V? I can write it as delta R by R. You can take two respective sides. So I am taking these two sides. So let me take these two sides. So what will happen? It will be delta R by R. Delta R divided by let me say R. Okay. So then what you can write for delta V equals to V into delta R divided by R. V into delta R divided by R. Okay. So if I write instantaneous acceleration for this one, this will be what? Instantaneous acceleration. If I write A equals to this is what? Limit delta V by delta T. Delta T tends to 0. So this will become dV by dt. So no need to worry about that one. So what we want is this. Okay. So now I will substitute that in the average velocity. So what is the average acceleration? So average acceleration is equals to what is this one? Delta V divided by delta T. So what is delta V? Delta V is V into delta R by R. V into delta R divided by R. So delta T is there as it is. Okay. So V by R will take on this side. So this is what delta R divided by delta T, delta R divided by delta T. So this is what average acceleration. Okay. So that is nothing but your velocity. But let me take the apply limit. So apply limit. If you apply the limit, A equals to limit delta T tends to 0, P by R, delta R divided by delta T. Listen properly, it is very important for your board exam. Okay. So acceleration is equals to V and R are constant, take outside, V divided by R I will take outside. I will apply limit delta R divided by delta A, delta T tends to 0. So A equals to V divided by R. What is that? What is this limit delta R by delta T? It is nothing but limit delta R by delta T is nothing but your instantaneous velocity. So let me write it as V. So acceleration equals to this V and V will become V square divided by R. So acceleration is equals to where I can write over here. So acceleration is equals to V square divided by R. Okay. So acceleration is equals to V square divided by R. Let me take R as capital R. So A equals to V square divided by R is what it is going to be. It is going to be what your acceleration. But what is the direction? It is always towards the center, because it is along the direction of what your delta V. So this is what direction of your acceleration. Means acceleration is towards center. When object comes here, acceleration is towards center. When object is here, acceleration is towards center. Okay, because when you go on changing, applying the limit, what is limit delta T tends to 0, what will happen? You will make this very small. Okay, so this is what the displacement. So what will happen to your A? Acceleration will be along this direction only. If you make delta T equals to 0 only, so what will happen? This is the velocity and this will become what your acceleration. Okay, so these all things we have studied in our straight line motion only, or sorry, in your vectors and beginning of the motion plane. So don't worry about this one. So you have to write all these things if they ask to derive the relation between acceleration and whatever. If they ask for derivation of centripetal acceleration. Now you may change this heading. Why? Because it is not only acceleration; it is acceleration directing towards center. Okay, it is acceleration directing towards center. So that is why it is called as what? It is called as centripetal acceleration. It is directing towards the center. So that is why it is called as what? It is called as centripetal acceleration. So let me change this as centripetal acceleration. Okay. So this is what the actual definition of this acceleration. Okay. When the object is in circular motion, the acceleration is what? Centripetal acceleration. Why it is? Because it is always directed towards center. Why it is called as centripetal acceleration? Because it is always directed towards the center. Always directed towards the center. So that is why it is called as what? Acceleration. They may ask you what is centripetal acceleration and derive the formula for centripetal acceleration. Okay. So for that you have to start from here. So this is not required. Okay. So you leave this part. You start from here. You have to mention what is P dash. You have to draw this one. This is also not required for that one, but if you write it, it's also fine. So final answer will be here. Okay. So this is what the derivation for centripetal acceleration when the object is in uniform circular motion. Okay. So what we got? Centripetal acceleration. acceleration when body is in uniform motion. That is what we can write v equals to A equals to p square divided by r. Okay, so usually when the object is in uniform circular motion, so it is always having two types of accelerations. Okay, so one is a tangent. This is what acceleration along the direction of the velocity. So that is what it is, the instantaneous acceleration that we can do by A equals to dv by dv by dt. Okay, so another is centripetal acceleration. This is what we can say tangential acceleration. Tangential acceleration. Okay, so what about this one? This is what towards center. This is what we can call it as A equals to v square divided by r. If r is what? R is radius. So this is what we can write it as a centripetal acceleration. Centripetal acceleration. Okay, so acceleration. So resultant of these two. Resultant of these two we can call it as what? Total acceleration. Resultant of these two you can call it as total acceleration. Where it will be? It may be somewhere here. Okay, so simply you can write it. Okay, so no need to worry about all these things, but you should know what is tangential acceleration, what is the acceleration. If they simply ask you to find total acceleration, we should not simply find the centripetal. You have to find centripetal, tangential, then you have to find the resultant. Okay, so it's very important to remember the total acceleration and tangential acceleration, and then what your centripetal acceleration, or you can call it as normal acceleration. Okay, so now if I take an example, suppose an object is moving in a circular path. Say its radius is say r equals to 2 meter. Okay, so r equals to 2 meter, and it is moving with a velocity say v equals to 4t. V equals to 4t. If they ask you to find A is the tangential acceleration. Tangential acceleration at t equals to 1 second. B is total acceleration. Total acceleration at t equals to 1 second again. At t equals to 1 second. Okay. So how we can do this one? So to find tangential acceleration, what you have to do? You have to differentiate this. So tangential acceleration A equals to tangential acceleration. So tangential acceleration is what? A equals to dv by dt. Okay. So what is the differentiation of 4t? d by dt of 4t. Differentiation of 4t is 4 is constant as it is. Differentiation of t raised to n into t raised to n minus 1, t raised to 1 into t raised to 1 minus 1. So t into t raised to 0 will be what? It will be 1, because t raised to 0 is what? 1. So you will get 4 into 1. So this is what answer is 4. So tangential acceleration is what? 4. What about centripetal acceleration? Here no need to substitute where t equals to 1 because t is not there already. For centripetal acceleration, so what you can write? V equals to 4t. What is the formula? A equals to v square divided by r. A equals to v square divided by r. Okay. So what about v square? 4t the square. So substitute t equals to 1 over t. Okay. Or you can simply say v. V at t equals to 1 is v equals to 4 into 1 will be 4. So substitute here. A equals to 4 the square divided by r is what? R is 2. So this will become 4 the square is 16. 16 by 2 is what? 8 meter per second square. You can use a different units that we will see later. Okay. So radian per second square will come. So, but you are writing in terms of units, you can simply write meter per second square. So resultant velocity is what? Resultant velocity is square root of tangential acceleration, sorry, not velocity, acceleration is tangential acceleration in the square plus centripetal acceleration in the square. So 4 the square plus 8 the square. So 4 the square is 16, 8 the square is what? 64. Okay. So 64, then 74 and 80. So this will become some root 80. So simply you will get the acceleration as root 80. Okay. So you can simplify also that you will get what exactly the value of that one. Okay. So simply you can take 64 or 16 5s. Okay. But you should write the units also, meter per second square. Here meter per second square. Here also you will get what meter per second square. Okay. So this is what all about the centripetal acceleration. Just today we had talked about the only centripetal acceleration. Okay. So there are so many things about the uniform circular motion. They have its own physical quantities like angular velocity, angular acceleration, whatever, angular displacement, angular position, all those things. So once we go through that one, you can understand this very easily. So that we will discuss in the next class. Okay.